Good morning, our listeners, and I welcome you to our today's class as we continue to make efforts to provide solutions to math problems in a way and manner that might leave us with little or no confusion on how to solve related questions. Today, we are still looking at a probability related question where we are told that if an event A implies obtaining prime number and event B implies obtaining an odd number in a single throw of a die, find the probability of events A or B. What we bear in mind here, which of course is the item in this trial, is a die. And of course, a die contains six faces, numbered from 1 to 6 inclusive. So in a throw of a die, 1 to 6 inclusive are all the possible outcome that one can have. So the total possible outcome in a throw of a die is 6. And of course, this total possible outcome in the language of statistics and probability can be called the sample space, which of course we define as the set that contains all the possible outcome of a trial. And in our own context, it ranges from 1 to 6 inclusive. So I can decide to come here and write sample space. Sample space. Hmm? And of course, in statistics and probability, this sample space is often denoted with a capital letter S. So I can write what? S equals. I earlier had defined this S, which is the sample space, as a set that contains all the possible outcome of a trial. And of course, in our own context here, we are discussing a die that ranges from 1 to 6 inclusive. So I have 1, 2, 3, 4, 5, and 6. This is the sample space here. And of course, there are subsets of this sample space, which are, of course, called events A and B. So we are going to, from this sample space, now deduce the members or the elements of the events A and B, which, of course, will equally be denoted as as events, or what we call as sets. But then before we progress, let us come back to this sample space. Of course, when we talk about cardinality of a set, we are talking about the number of what elements that are contained in that set. And conventionally, it is always written as what? N. It is written as N of what? S. What this means is what? Number of elements that are contained in this sample space, S. And of course, they are 1, 2, 3, 4, 5, 6. So the cardinality of S, sample space, is what? Is 6. So that one is over. Then we come to what? To a set A. We are talking about a set A, which is a set containing all the prime numbers that are found between 1 and 6 inclusive. Of course, a prime number is a number that has two factors, 1 and itself. So in that case, 1 does not qualify to be a prime number because it doesn't have two factors. 1 is 1, and I don't know, in fact, not I don't know, itself might not be there. So when we come to this word 2, of course, 2 is a prime number because it's only two numbers that can divide that it has only two factors, 1 and itself. 1 can go into 2 without a remainder, and 2 can go into 2 without a remainder. So I'll open a bracket, I'll write word 2, comma. Of course, 3 is equally a prime number because 3 has only two factors, 1 and itself, which is 3. 1 can go into 3 without remainder, and 3 can go into 3 without a remainder. So I'll write word 3, comma. Of course, 4 is not a prime number because 1 can go into 4 without remainder, 2 can go into 4 without remainder, 4 can go into 4 without remainder. So we are looking at 3 factors here. But we see for it to be a prime number, it must be two factors, 1 and itself. So we come over here. 5 is a prime number because it has only two factors, 1 and itself. So I'll write what? 5. 6 is not a prime number. 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into 6. I'll close it. And then you agree with me that this is now a set of prime numbers. And if I want to count the number of elements in what? In A, I'll be able to have that n of what? A equals what? 3. That is the number of elements in what? In that set what? A equals what? 3. So I am down to set what? B. In the set B, we are talking about the odd numbers. And of course, in odd numbers, we are looking at numbers that cannot be divided by 2 without a remainder. Of course, 2 cannot divide 1 without a remainder, 2 cannot divide 3 without a remainder, and 2 cannot divide 5 without what? A remainder. So I am looking at what we call what? 1, comma what? Yes, we are talking about odd numbers. We are talking about 1, 3, and 5. These are what we call the odd numbers. Okay, if these are the odd numbers, of course, that cannot be divided by 2 without a remainder, then we now talk about what? I have what? My n of b. My n of b equals what? 3 as well. Equals what? 3 as well. So we now move further. Yes, moving further here now, we are now going to look for the probability of getting the event A and probability of getting event what? B. But before we go ahead, let us look at the fact whether there is anything that is shared in common by a set A and a set what? B, which of course is called the intersection of a set A and a set B. So I have A intersection what? B equals, I'll open. A intersection B means all the elements that are contained in A which are equally contained in what? In B. When we look at here, there is 2 here, there is no 2 here. There is 3 here, there is 3 here, I will pick it. There is 5 here, there is 5 here, I will pick it. So I have that my n of A intersection what? B equals what? 2. So I will now go and look for probability of A occurring, which I'm going to write as what? P of what? A. What I mean by P of A is probability of this event occurring. This equals, I have what? N of what? A all over what? N of what? S. What this means is number of elements in the event A all over number of elements in the sample space. And number of elements here is 3, and number of elements here is 6. So it becomes what? 3 over 6, which equally becomes what? 1 over 2. Then I go over now for that of what? B. So I will have what? That P of what? B equals N of what? B all over what? N of what? S. Which of course becomes what? 3 over 6 equals what? 1 over 2. Okay? So I will now move a step further and look at the probability of their intersection occurring, which becomes what? P of what? A intersection what? B equals. I have what? N of A intersection B all over what? N of what? S. And of course, the n of A intersection B is given as what? 2. And then the n of x is given as 6. So it still remains what? 2 all over what? 6, which equals 1 over 3. But then before we can answer this question finally, we are going to look at 2 terms, which we call mutually exclusive events and non-mutually exclusive events. When we say that events A and B are mutually exclusive, what we intend to say is that A and B cannot occur together. And if they cannot occur together, it means that their intersection is what? Is 0. But in our own case here, the intersection isn't 0. The intersection contains 2 elements, 3 and 5. So this kind of trial is a non-mutually exclusive event. That is, A and B are non-mutually exclusive events. And we are given what we call a formula of obtaining the probability of A or B in mutually exclusive event. And that thing we equally need to bear in mind is when we use this word A or B, we are talking about either A occurring or B occurring. And in a set language, A or B is written as what? A union B. So an A union B, of course, in non-mutually exclusive event is given as that the probability of A union B equals probability of A plus probability of B minus probability of A intersection B. That is how we write it in a non-mutually exclusive event, because we are saying that A intersection B isn't a null set in a non-mutually exclusive event. And of course, A union B means probability of A or B. So with this, we'll be able to find our answers or our answer faster. We have obtained the probability of A, we have obtained the probability of B, and we have obtained the probability of A intersection B. So what we're going to do is to plug in these values we already have computed into this problem. And then I have that therefore I have P of A union what? B equals. Probability of A is what? 1 over 2. Probability of B is 1 over 2. So I have 1 over what? 2 plus 1 over what? 2. Here is what? Minus. What I have here is 1 over 3. So I have 1 over 3. Of course, the LCM of what? 2 and 3 is 6. So I can write this in, this equals, I have this into the what? 6. And I'll say 6 divided by 2 is 3. 3 times 1 is what? 3 plus. 6 divided by 2, 3. 3 times 1 is what? 3 minus. I have 6 divided by 3, 2. 2 times 1 is what? 2. This equals. This is 3 plus 3, which is 6. So 6 minus 2 is what? 4. So I have that this is what? 4 over what? 6, which of course becomes what? 2 over 3. So the probability of having A or B when a die is cast and A and B are sets with which we collected the events of prime numbers and odd numbers is 2 over 3. Thank you very much. We really want to believe that you did not have a problem as we provided the answer to this question. We ask you to please share, comment, like, and follow us on our pages in different social media platforms. And stay tuned for the next classes. Thank you very much, and God bless you.